Red Hat OpenShift is the sponsor for our container platform coverage from OSCON in Austin, Texas. OpenShift reaches across open source communities to collaborate for healthy upstream development. The goal? Ensure the support for features and functionalities that end users require across the overall ecosystem. You can learn more at openshift.com. Hey, Alex Williams, the New Stack here at OSCON. It's Open Container Day. We're talking about container platforms. And Steve, you're with Red Hat.
I am for the last 4.5 years.
And tell us a little bit about what you do there.
I'm what you might call a chief complainer, which Red Hat is really good at accepting. I'm the lead developer evangelist for OpenShift Online.
Okay.
So what that means is I go out and I talk at shows like this, or I do workshops, and then I go back and complain to the engineers about all the things that need to be fixed and taken care of.
So we were just talking beforehand about, a topic for us to chat about. And it's one I think that we start to overlook a little bit now that the discussions have become so much deeper about containers. But we often, I think, overlook what it's like to develop, what it's like for a developer to develop with Docker, right? And because it can be quite simple to start, but you wanted to, talk about this, and I think it's a great topic just because, we're talking about so many different complexities now, and I'm curious about, at what point does it just become so difficult for that user out there, you know? And so what is it like in that experience now for the developer?
So containers have actually made a lot of things easier for developers, right? Because you could say this code that's running on my machine is exactly like the code running somewhere else.
Right.
So that's nice. And you can also have your sysadmins give you a container and you spin it up and you know it's going to work the way they want it to work. But and it's easy to play with. Like you do the Docker tutorials and you build a little Docker file and you say Docker run or Docker build, Docker run, and wow, look, I just spun up Tomcat. But I think what ends up happening is after that initial period, a lot of developers, they start to build stuff and then they're like, oh wait, how do I actually get this up somewhere? How do I actually do testing against it? How do I actually orchestrate all the services together? How to get
it off their laptop.
Exactly. Right. And so you can even do stuff like with Docker Compose and get 2 containers to work on your machine.
Right.
And they're talking to each other, but then it's like, okay, well, I can't really use Docker Compose in production, so now what am I going to do to get it to the next level? And so that's where I think there's like at least 3 different big projects that I know of that are doing this. So there's my project, which is OpenShift and Google's Kubernetes. That's where it takes it to the next level. Then there's Mesosphere's Mesos project that also does that kind of stuff. And then Docker Swarm. So those are those 3 next level projects that are kind of trying to help developers and sysadmins get past, oh yeah, I made this cool little Docker container on my desktop.
Right.
And I think one of the other things that developers run into that's a problem is if you just use straight Docker, your build flow changes as well.
Go on.
Okay. So your build flow changes as well in terms of, usually you're used to, if you're a Java developer, you'll use something like Maven, right? And so there you're used to doing like Maven build, or your tooling will take care of Maven build. But what ends up happening in Docker is because Docker containers are immutable, you can't do that. You can't just put the code in there and then have it live. You actually have to build a new Docker container. So it changes the flow. So some people have been working on that. It's really, I think, so in one of the other talks I give, I say that we're at a time of container, like the Cambrian explosion in evolution, when there was all that.
You're the second one to bring that up today.
I think they stole it. Who said it?
Adrian Cockcroft.
I think he saw my talk and stole it. I think he did, because he can go back and I have this.
Adrian.
Yeah, I know. I mean, what has he done? Microservices and Netflix. So I talk about this being the container explosion. Like we're at a time when there's, and so when people say, oh, we've got the solution, I don't think anyone has the solution right now. I think there's a bunch of different people working on the same problem with different solutions to that. So I actually find it quite exciting to see how different groups are playing off. And the big problems that we're solving for developers are 1, how to get your code into the container, and then 2, once you've got that container, how do you actually make a full application?
What are the automated practices that are starting to emerge for developers so they can just get it up and running faster? We see things like from Bitnami, they have their Stacksmith, for example. that seems to be a method for, getting that Docker container ready.
Ready faster.
Yeah.
And I think that, so when I think back to like V2 of OpenShift, which wasn't even using Docker, but what was using containers, that made life easier too. You just said, I want a Tomcat container, and it spun it up, and you just gave it code. I think what you're seeing is a lot of these different platforms, what they're doing is giving you an automated way to take your container and run it, right? So, for example, with Kubernetes, you can just say, take this container and run it, and it builds all the other things around it and runs it. You were giving the example of Bitnami. I mean, everybody's doing it. Azure has a container service now.
Right.
AWS has a container service now.
Right. What is a container service anyway?
Well, who do you ask, right?
That's a question. Yeah.
Yeah. So everybody thinks they're running a container service in the same way that everybody used to be running a platform as a service.
Right.
I think the basic idea with a container service is it's a way to get your container up and publicly hosted rather than on your laptop.
Right.
But then it also has a way to like orchestrate between your container and other containers so that they can talk, you can scale them up, you can move them around, that kind of bring it down, bring a new one in. It's more of the orchestration and scheduling above and beyond containers and networking and routing, that kind of somewhat interesting stuff to developers. But, okay, so here's the deal though. This is why container application services or whatever container services are important for. In the end, I don't think most developers care about containers. Don't you need me to sit closer?
No, go ahead.
I don't think most developers care about containers one bit in their day. I mean, they're cool.
Yeah.
But the thing that most developers care about is, I wrote my code, it worked, and I didn't spend all my time yak shaving trying to figure out how to tune my Tomcat.
Yak shaving?
Yeah, so this
I haven't heard that term.
You haven't heard that term?
No.
So this is a two-term. I'll give you another one also after that.
Okay.
I have these favorite terms. So yak shaving, I think this one came up. I forget exactly where it came up. It came up on some mailing list, and the idea was the basic. I know I'm going to get parts of it wrong, but you want to go check your mail, and you live in Alaska.
Right.
It's cold outside.
Right.
So you need to put on a sweater before you go outside.
Right.
But you don't have a sweater.
Okay.
So you basically have to then get some wool. Well, you
Right.
don't have some wool. So now you got to go get some wool so that you can knit the sweater to go outside to check your mail. Well, so then you go outside to shave your yak for the day. And at the end of the day, you've spent your whole day shaving a yak and you still haven't gotten your mail.
Okay, what's the other one?
The other one is bike shedding. Have you heard bike shedding?
No.
I'm pretty sure this one came up.
I've heard of that, but tell me again.
Okay, that one I'm pretty sure comes off the BSD list really
Okay.
early on. And it's the idea, there was a junior developer who wanted to make a very simple fix to the kernel. It was a very simple thing. And there was this huge, long discussion with lots of opinions about how to get it done. And so this guy said, this is a typical bike shedding scenario. If you try to build a nuclear reactor, that's a very complicated thing. You hire a bunch of PhDs and all these civil engineers, and there's a huge report, and nobody can understand it, so they all kind of stamp, oh yes, and they stamp it and it moves on. But you say you want to build a bike shed, and everybody can get their head around how to build a bike shed, so they're like, oh no, the door has to be over here, and when I built my bike shed, I needed to paint it red rather than blue, and so you have endless discussions about the bike shed because everybody feels like they can talk about it when it just move it on and let's go. So that's bike shedding.
Okay.
That's like website design, right? Where everybody feels like they know how to design a website. So they say, oh, no, it's got to be green rather than blue there.
Right.
And no, the font has to move a little bit this way. And so I feel very bad for web designers because everybody feels, or UX especially.
So where were we with containers in those kind of, in terms of those, those
I think
analogies?
yak shaving. So what's happening with those analogies is container platforms is helping developers to get rid of a lot of and containers themselves are helping developers get rid of a lot of yak shaving, right? Because they don't spend their time.
They don't have to shave the yak anymore.
It's just like, oh, here's a container that has Tomcat set up the way we want to run it into production here. So you can put it right. Just put this container on your desktop and run it. And when you're deving against it, you're deving against the exact same container that we're going to be running in production. Oh, you want to figure out how this is going to talk to your ActiveMQ service, and then you're also going to plug that into your database. Fine, the container platform will spin all those things up on your desktop. You'll play with them there now, rather than, oh, I did it this way on my desktop, installing all those pieces, and now when I move it to production, I have to do all these changes manually. It gives you a way to like worry about your code and not about all the other stuff that you wanted to do, that you didn't want to do to try to get your code working. So that's the yak. It gets rid of a lot of yak shaving.
So is that the term we're hearing in relation to containers now, is yak shaving, or are we hearing other terms too?
Well, you hear automation a lot, right?
Yeah. But I'm looking for
developer terms?
like funny terms like that.
Yak shaving's been around a while. I haven't seen any other really funny
Well, there's the cattle. There's pets versus cattle.
Do you want me to give it? I have a whole opinion piece about pets versus cattle.
Yeah.
Great. This is a favorite one of mine. I think that is the worst analogy ever.
Right.
And I want people to stop using it immediately.
Immediately now.
No more using pets versus cattle, for two reasons. One is a religion, like not my religion, but a religious, like offensive reason, and two is for a biological reason.
Okay.
So first of all, saying that you're going to take, for those who don't know what cattle versus pets are, the original. Can I explain to your audience?
Yeah, go ahead.
Okay. So cattle versus pets. When the first people came up with
kind of like a slaughterhouse.
Yes, exactly.
Model.
Pets are your VMs. You care about them a lot. You give them names. You put a lot of resources in them. When they sprain a toenail, you actually take them to the vet and spend $10,000 on them, right? And so those are pets, and those are your VMs.
Yeah.
So you keep those up, and you put a lot of energy in.
Yeah.
Containers, they're like, so this is the wrong analogy. They say that they're like cattle. So a cattle's out in the field, it breaks its leg, you put a gun to its head, you shoot it, and you just move on.
Yeah,
right?
that's real nice.
Yeah, so it's all interchangeable. You don't really care about your cattle. You just they're all the same, and you can swap them in and out. So one, that analogy is totally offensive probably to about 1 billion people in the world.
Yeah, at least.
So I would say for that reason alone, we should ditch it. But even more importantly, in my former life, I was actually a conservation biologist. I have a PhD in ecology, and I've done...
Okay.
So I've gone out and talked to ranchers when we're doing these habitat conservation plans, because a lot of times they have good land and it's helpful. Yeah. And they care a lot about their cows. They spend a lot, like every cow is thousands and thousands of dollars, and they spend so much money in vet bills and and they all have names. I mean, it's a number, that's a name, but they all have, they track all their cows. If a cow doesn't come home for the night,
they know.
They don't oh, well, lost another cow. Oh, well, no big deal, right? Like, that's a huge deal. You're going out to get that cow. So the analogy I like better, and this is coming from my biology background, is elephants and ants. Elephants and ants. Yes. Elephants care a lot about each and every member of the herd. They put a ton of energy into protecting the herd. They follow the whole herd will protect offspring and raise them. Okay. And when elephants die, they have graveyards. They'll go back and revisit them. Mm-hmm. They care a lot about it. So that's your VM. Ants, they don't care a lot about each other. Like, if you go out there and squish an ant by accident, they'll move around it, and then they'll come pick it up and probably bring it back and feed it to others. There's no mourning period. There's no, and they are actually very interchangeable in their work. So like, you need another ant to help you move that moth across the field that's dead. You bring in 5 more ants. One of the ants happens to get eaten by a flicker on the way over. You're just going to bring another ant in. So, they actually are all genetically identical. Like, all the ants in a colony are all sisters. So it's like they are a much better analogy than cattle and pets. Is that whole analogy just wrong, though? Because now, I mean, I guess there's an ephemeral aspect to what you're saying there, too. So I think also part of what it's trying to do, and when I do like my microservices talk, or when I do my other, like, using containers in production talk, what I try to do is, developers my age, and I would say even 10 years younger than me, so I'm 46, so even in their mid-30s or whatever, we grew up in an era of, if I want my box to be highly available, I have one box for the database server and one box for the app server, and it's got 2 power supplies and RAID 1 or RAID 5 on the disks. Like, we didn't really think that, like, we bought into this whole lie that nothing ever goes down. Usually you'd put everything on one box when I was first writing applications, and you would make the box redundant, but there was this lie that, like, your database would always be up. Right. And there would be, your app server would almost always be up. And we've learned over time that's really not true. And so I think what's the nice part about the ant analogy is to get people to thinking, like, no, that lie's not true. And I should expect my ants to die. Like, I should build my system such that ants can come or go, and it won't stop my system from working. Mm-hmm. To stop thinking about things being so precious and keeping that one piece up. And I think we have a long way to go teaching developers how to think that way. Actually. Someone actually was comparing it to Battlestar Galactica. And I've never seen the series, but apparently, like, there's like these, there's this clone army. Okay. And basically the clone army can just kind of appear out of nowhere. Right. One of these clones can just appear out of nowhere, right? Right. And it just like bloop, like pops up. Right. And then, or it can just go away. Right. Right. So, I mean, it can be that exact same thing. Like, you have, the resources can come up almost instantaneously, and they can go away when you don't need them anymore. So that's another benefit as well. But I think for me, that is definitely a benefit of containers and the platform. I think for me, the bigger challenge we have with developers right now is teaching them how to think in terms of clustered software. Maybe not the newest developers who are out right now who never grew up with physical boxes at all, but for developers like in their 30s and 40s, for most of them, not all of them, but for most of them, I think the biggest challenge we have is to teach them how to write their applications to scale horizontally rather than vertically.
Yeah, because now first of all, there's an identity issue there, right? Like,
right.
What is my role as a developer? Like, how do I fit into this whole new world where the workflows are different, but not only that, but you have a whole different set of constructs.
Very
right?
much so.
The constructs now, for example, we interviewed someone from Cumulus,
right?
And he was talking about, like IP, right? That's a construct that had very much was very relevant, I would say, for developers 10, 15 years ago, right?
Right.
But now IP doesn't necessarily have as much relevance.
Right. I mean, with the rise of the there's still IP in open source, but it's not IP used to stop you from using the stuff.
Right. 15 years ago, you would never have talked about instances, right?
Right.
What the heck's an instance?
And what's an instance? And now
an instance is like just used in the language to describe, what you're talking about, cluster software.
And I think that's an interesting transition. And so some people sometimes ask me, why have containers become so big right now? And I actually say that VMs was a big ice-breaking ship for them. Because I think once people made the shift from, I need my physical machine to, I've actually got a VM that's a part of this machine and it still works well, then they're like, okay, you can keep giving me virtual things. So, because containers have been around a long time, right? Solaris had zones, I remember almost 2004, 2000, I don't know, it was pretty early on. Actually, even might have been in the 90s.
Right.
And they were awesome, but I didn't know of anybody really using them. And BSD change root jails, they've been around for a long time. I think it's the VM switch, the people getting comfortable with VMs and Amazon, and now okay, things are ephemeral. Things can spin up. It's not a real physical machine. The container's an even lighter weight version of that, which won't cost me any money to extra licensing fees to run. Awesome, I'm on board with that. Let's give it a try. And it actually configures the bits on it as well. I think that's great. So let's give it a try. So I think they didn't just pop up out of the ground, containers, and everybody was like, awesome. They've been around. We just needed some historical conditions to help plow the way.
So now we're moving forward in things, and now we're starting to see kind of a whole new emergence of not just the developers figuring out how to use containers, but how operations teams start to use containers.
Right.
What are your reflections about that? Because this is now a whole new realm.
Yeah,
but it very much still relates very directly back to the developers.
Yes.
Because what's different about clustered software, right, is that the developers are actually consuming the infrastructure.
They're consuming the infrastructure. It's not like you can't assume that your laptop is going to be with in terms of the container, your lap, it's going to be the same. But you can no longer. We used to think I've done this POM file, and then I'm going to toss it over the fence to the sysadmins, and they'll do their special build, and they'll produce something in production. And I don't think that really flies as much inside of less and less so. It flies inside of companies. I'm going to just chuck something over the wall to you, and you'll make it production ready.
Right.
They need to start thinking from production ready right from the beginning. So, I think what containers actually give us the ability to do is for more clear communication between developers and sysadmins.
Right.
Because one of the customers I went to go meet with, the sysadmins actually loved it, and they were pushing it to the developers, and they would say, the developer would come and say, I found this really great Docker image on Docker Hub. I really want to use this. And the sysadmins would say, great, give me the Docker file. And so then they would take the Docker file, but then rebuild all the layers inside the Docker file using software that they approved of. It was almost the exact same container, just using approved layers inside of it. And then they gave that to the developers and okay, now use it. You got exactly what you wanted. It was very easy for me to figure out what you wanted because I could just look at the Docker file and do it. And then when you're done with your development process, just give me the Docker image and I'll deploy it. And on certain other things now, Jenkins used to just do tests against your code and then maybe produce a war file. Jenkins now can actually produce the entire Docker file that can then be deployed as well, which sysadmins love too, and then even in financials, right? Because each Docker image has a SHA key on it. It's got a unique number.
Right.
So when there's a when there's regulators come in and say, we want to see that the binary that the developer built or that was built that passed, actually it's the binary that passed all the tests is the one in production. You can say, well, there's the two SHA numbers. They're exactly the same. Or, hey, that SHA number's changed. Somebody did something somewhere, right? It allows for where you couldn't do that if someone just played with a configuration file. You'd have to run diffs on all your configuration files on all your machines.
Wow, yeah.
Right now, you can just say, what Docker image is running? It's that same number. Great, we're done. So, and the other thing it does, and this is something. So at the first DockerCon, I was in the back with Dan Walsh. Yeah. Put SE Linux and Linux. So we were talking, and one of the things he was most excited about with Docker was that it was going to get rid of RPMs. Because RPMs just put the software down on the machine, right? You still have that whole configuration step. You have all that other work to do. He's like, now we can actually deliver the bits and how it's supposed to be configured,
right?
Which is a huge step forward compared to like, RPM install, and then read this 30-page manual on how to configure it, right? Now it's just like, okay, take the container, put it on your machine. Here's some environment variables you can use to tweak it. Other than that, go. So it just changes the whole conversation for everybody.
It changed a lot.
Yeah.
Well, Steve, thank you very much for taking the time to talk. I really appreciate it.
Yeah.
And look forward to hearing more about, perhaps we can at another time think of some different analogies for the growth.
I love analogies. I'll keep my ears open.
All right, thanks.
Thanks, Alex.
Bye. Red Hat OpenShift is the sponsor for our container platform coverage from OSCON in Austin, Texas. OpenShift reaches across open source communities to collaborate for healthy upstream development. The goal? Ensure the support for features and functionalities that end users require across the overall ecosystem. You can learn more at openshift.com.